In this video, we're going to explore some of the properties of SIMAC that allow us to investigate the relationship between the beam energy and the beam flatness. So what I'm going to do is I'm going to load in a few different beam energies, and I'm going to load in some pre-made flattening filters, and we're going to look at the effect of having a beam flattening filter which is not the correct setup for the beam energy that we're looking at. And also if you have a beam energy which is higher or lower than what the flattening filter was designed for. So I have SIMAC is loaded. I'm going to load up a 6 MV beam. So we do that by loading up our 6 MV beam here. Now we have, so these are the default parameters. And what I have is in the flattening filter, we have our default mode filter selected. So that was chosen. And if we go and look at in the analysis tab, we can see what the profiles look like. So these are the radial and in-plane profiles as well as the depth dose. And if you recall, the default mode filter for the 6 MV mode was not a very well designed filter, so it's got the flatness is not very flat, and the beam is a little more intense at the center than we would like it to be. So I'm going to go and fix that by pulling in a improved flattening filter for 6 MV. So I've done that. That's loaded up successfully, and then what we have over here is we have the improved profiles. And what we can do is we can go and look at the differences between these filters. And so here is our default filter. So this is the filter that was programmed in. And so here are it's made out of copper. These are the thicknesses of the copper filter as a function of the radius of the filter. Then the improved filter is going to be a little different. So now we have a slightly thicker at the center than the other filter. And again, we can look at the profile again, and we see that that's flat. So what I'm going to do now is I'm going to change the beam energy to a 4 MV beam, and then we're going to look at how this affects the profiles. So what I have here is I have some parameters that I've predetermined, which I'm now going to load in here. So these are numbers which I determined before doing this video. So I'll just type these in rather than going through the exercise of determining what they should be. So there we go. So now I've entered in the parameters for a 4 MeV beam. So we have the accelerators making 4.03 MeVs, and the bending magnet is set to let 4.02 MeV pass through. So now we haven't changed the flattening filter, so this is still the same flattening filter as before. It's our 6 MV improved flattening filter. So what we should expect to see an effect on this beam symmetry when we look in the analysis tab, and that's what we see. So we see a rather odd shaped profile. It looks more like an M rather than the kind of profile that we would expect to see in a clinical radiotherapy machine. And the reason why it looks like this is because we still have the flattening filter designed for 6 MeV, so it's going to attenuate more at the center than it will at the side because of its profile, its thickness profile. And because now the beam energy is lower than what the flattening filter was designed for, then we have this attenuation that's higher in the center and then less at the side. So we have a very odd shaped profile. So that's not the kind of profile that we would like to have in a radiotherapy machine. So what I'm going to do now is I'm going to go and I'm going to correct this by I'm going to load in a flattening filter that was designed for a 4 MeV beam. And again, I've pre-built this, so we can just go through and load it up. So the way we do this is we go back into our SIMAC tab, go over to the flattening filter, and we pull up in our menu. We have the 4 MeV flattening filter, which I've pre-built. So we have over here, so we can look at that. And then we can go back to our analysis tab, and we see that now we have a flat beam. And we can go and look at what this filter looks like. So now we go to the filter tab. We bring this up. Here's our 4 MV filter. Now this filter, I've made it out of tungsten as opposed to copper. So now the thicknesses are quite different. Because tungsten is a higher density material than copper, and right now SIMAC allows either material to be used. And so then again, going back to our analysis tab, we see the flat beam. So what I'll do is I'll go back to now the 6 MV beam, and we'll see what effects now this has on our flattening filter. So if I go back, and that's easy, the easiest way to do this is to simply cycle this off and then pull in a fresh 6 MV beam. So now this loads in the default parameters for the 6 MeV beam. So we have 6 MeVs. We haven't changed the flattening filter, so that's still the same flattening filter. It's our 4 MV flattening filter. And now what we expect to see is a different kind of shape, because now we have the beam energy is higher than what the flattening filter is designed for. And when we go back and look at this, we have now a profile that's more like a hump, like this. So that's not what we were, again, not the kind of profile that we would like to see on a clinical radiotherapy machine. So what I'm going to do is I'm going to make this now even worse. I'm going to load in an 8 MV filter, and then so this is going to get exaggerated even more. So again, I have one pre-built. So now I'm going to go here and select this. So here's our, I'm going to load in an 8 MV beam, not an, and then we'll do the filter later. So the 8 MV beam, I have the parameters again defined for that. So I'll just enter these. So there we go. So now again, so our accelerator is making about an 8 MeV beam. The bending magnet is allowing 8 MeVs to go through to the target. And we haven't changed our flattening filter. So when we go back and look at our analysis tab now we have a beam which is even more forward directed, because now we have an even higher beam energy, which is incident on a filter which is designed to flatten only 4 MeV beams. So now what I can do is I can go and I have a filter that was built for 8 MeV. So this is over here. So I've built this over here. I'll just bring this up. So this is an 8 MeV filter. So it's much thicker to center. See, 0.8 centimeters as opposed to the 4 MV filter, which was 0.355. And again, this is made out of tungsten. 8 MeV. This is made out of tungsten. So now going back to our SIMAC screen, I can now apply the 8 MeV filter. And we go back to the analysis tab, and now we see a flat beam. So that was successful. So now the one last thing I'm going to do before we finish this demonstration is I'm going to go and demonstrate how SIMAC can also simulate a flattening free filter mode, which is actually quite easy to do. We can go into our filter tab here, and I have the 8 MeV filter loaded. What I'm simply going to do is I'm going to just change all these numbers to 0 and save that, and then that will be the new filter design, which will be a very bad 8 MeV filter, but it'll be a very good 8 MeV flattening free filter mode filter. So I will now just change all these to zeros. If you actually have in SIMAC, you need to have a little bit a number here, a little bigger than 0, because it doesn't like 0, but if we just make this slightly higher than 0, SIMAC won't complain. So we'll go through and we'll do this for all of the thicknesses. I'll just enter this manually just to show how you create a different flattening filter. So what I'm just doing is I'm entering in the 0, and then I'm hitting the up arrow key to give the next highest, the lowest number that 0 that SIMAC will take, and that saves me typing. So that's that. So now I'm going to apply the new thicknesses. So now they've all been recorded. Now I have to save this, so I save that, and now that filter has been saved to the 8 MeV filter. So now we go back to our tab here, and I'll just make sure we still have that one selected. We do. So now if I go back into the analysis tab, what we now have is we have essentially a beam, this is the raw beam now coming from the target with no attenuation through a flattening filter, and we see a very forward directed beam. So this is a way that SIMAC can simulate the flattening free filter mode. So this is, again, just a short video to demonstrate some of the features of SIMAC and how you can explore the relationship between beam energy and beam flatness, and also understand how you adjust the beam flatness using a flattening filter.